We may have been celebrating the wrong milestone. When Voyager 1 crossed what was described as the boundary of interstellar space, headlines presented it as humanity's first step beyond the solar system. At last, a human-made machine had left home. It sounded like a frontier moment, the edge of everything familiar, the doorway leading outward. But that boundary is misleading. The solar system is not some vast continent that we escaped. Compared with the galaxy around it, it is closer to a single grain of sand on a shoreline extending for 100,000 light-years. Getting beyond it is not the beginning of the journey out, it is barely the first inch. That leads to the question almost no one asks. Forget leaving the solar system. How long would it take to leave the entire galaxy? What would it require to escape the Milky Way completely, turn around, and see the whole thing from outside? The answer is not simply an enormous number. It is something stranger. For anything humanity has built so far, or is even close to building, the honest answer can be expressed in one word: never. Here is why. The scale you cannot see. First, discard the picture of the Milky Way that probably exists in your imagination. Most people picture it as it appears in an astronomical photograph, a bright, orderly pinwheel viewed from above with a definite outline and an obvious direction in which a spacecraft could fly until it emerged into open space. But you have never actually seen the galaxy from the outside. No human being has. No camera ever made has photographed the entire Milky Way, and no future camera will be able to do so in the simple way those images suggest. Every complete picture is a reconstruction, an informed artistic representation assembled from measurements made while we are deep inside the structure itself. From within, the galaxy is immense beyond ordinary intuition. Its disk stretches for approximately 100,000 light-years from one side to the other. Light is the fastest thing known to exist, moving at about 300,000 kilometers every second. Yet even light needs 100,000 years to cross the galactic disk just once. The region containing us is a luminous sheet roughly 1,000 light-years thick. Within it are somewhere between 100 billion and 400 billion stars. Our own sun is not close to the center. It lies about 27,000 light-years from the galactic core, situated in a comparatively minor spiral arm, and roughly halfway between the brilliant central region and the dim outer boundary. Try to make that distance feel tangible. Imagine shrinking the whole Milky Way until it was the size of a country. On that scale, the distance separating the sun from the nearest star beyond our own would be thinner than a human hair. After more than 45 years of travel, Voyager 1 has not even crossed the equivalent of that hair. So we are not standing on a convenient map, looking around for a marked exit. We are embedded inside a structure so enormous that the ordinary meaning of the word distance starts to fail. Before asking how quickly a spacecraft could travel, we have to answer a more basic question: which direction actually leads out? The answer is not the one most people would expect. The two exits. There are two broad ways to try to leave the Milky Way, and one of them is a trap disguised as the obvious route. The intuitive choice is to head for the rim. You would fly sideways through the flat plane of the galactic disk, passing beyond the spiral arms and continuing toward the visible edge. It feels right because that is the direction in which the galaxy appears widest. In every familiar image, it looks like the path that most clearly means away. Yet from our position, about 27,000 light-years from the center, reaching the far edge would mean crossing more than 25,000 light-years of the galaxy's most crowded territory. That route would carry a spacecraft through gas clouds, regions where new stars are being born, and the combined gravitational influence of billions of suns. It is an immense distance through a densely populated part of the galaxy. And there is a much shorter direction, one that almost nobody instinctively considers: straight upward, or straight downward. Remember that the galactic disk is only about 1,000 light-years thick, and the sun is located fairly near its middle. Rather than traveling sideways across tens of thousands of light-years, a spacecraft could move perpendicular to the disk, passing through its upper or lower surface. In theory, it would leave the visible plane of the galaxy after traveling only about 500 light-years. That is roughly 50 times shorter than the journey to the rim. For a brief moment, the problem seems to have been solved. It looks as if we have discovered a shortcut, a kind of cosmic cheat code. Point the spacecraft upward, and the galaxy appears thin enough to escape. That is precisely when the trap closes. Passing beyond the bright disk and leaving behind the stars of the spiral arms, the glowing river of light we call the Milky Way, does not mean that you have left the galaxy, not even remotely. The visible disk is only the smallest portion of the material and mass that keeps the Milky Way together. The real galaxy extends far beyond the part that shines, and that unseen structure is not going to release a spacecraft simply because it is moved above the stars we can see. The invisible cage. Once you rise above the bright disk, the sky would grow dark. That darkness might look like freedom, but it is actually the moment when the cage becomes visible in another sense. A spacecraft leaving the glowing part of the galaxy would expect to find empty space on the other side. Instead, it would still be inside the Milky Way, inside the regions that emit very little light. Surrounding the disk is a huge, faint sphere known as the halo. It contains some of the galaxy's oldest stars, along with approximately 150 globular clusters. These are dense knots holding hundreds of thousands of stars each. Some orbit tens of thousands of light-years above the plane that might have been mistaken for the galaxy's outer edge. Even those halo stars are not the main obstacle. The greater problem is something that cannot be seen at all. The Milky Way is immersed in an enormous envelope of dark matter. It does not shine, it cannot be touched directly, and its presence is inferred through the gravitational effects it produces. The amount of this unseen material is staggering. Dark matter outweighs all the stars, planets, and atoms of ordinary matter in the galaxy by approximately 5-to-1. Its envelope does not stop at the end of the luminous disk. It reaches outward for hundreds of thousands of light-years, creating a gravitational enclosure that makes the bright spiral trapped within it seem surprisingly small. The strength of that enclosure can be expressed numerically through something called escape velocity. This is the speed an object must reach in order to break permanently free from a body's gravity instead of slowing down and falling back. Near the Sun, the escape velocity from the Milky Way is approximately 550 kilometers per second. 550 kilometers every second. Not every hour, but every second. Keep that figure in mind because everything that follows depends on it. To leave the Milky Way, a spacecraft cannot merely travel a great distance. It must move faster than 550 kilometers per second. It would have to accelerate enough to pull itself free from the gravity of a mass that cannot be seen, cannot be touched, and cannot be steered around. That reduces the entire question to one brutally simple test. How fast can we actually go? The number that ends the dream. This is where the dream begins to fade, quietly and without drama. Voyager 1 is the most distant object humanity has ever launched. It has been traveling for more than 45 years, and its speed relative to the Sun is about 17 kilometers per second. By any human standard, that is astonishingly fast. But compared with the Milky Way's escape velocity of 550 kilometers per second, it is almost negligible. Voyager is moving at only about 3% of the speed required to get away from the galaxy permanently. Of course, Voyager relies on technology that is decades old. Surely our newest spacecraft can do better. It can. The Parker Solar Probe was sent around the Sun in the tightest and most extreme orbit humanity has ever attempted. That spacecraft has reached roughly 192 kilometers per second, making it the fastest human-made object ever recorded. That is an extraordinary achievement in engineering. Even so, it is still almost 3 times slower than the speed required to break free of the Milky Way. At its absolute maximum, our fastest object would eventually lose its momentum, come to a halt, and fall back under the galaxy's gravity. Take a moment to consider what that really means. Escaping the Milky Way is not simply a matter of waiting for a very long time. At any speed we can genuinely achieve, escape would never happen at all. The spacecraft would not crawl towards some faraway boundary and eventually pass through it. Instead, it would settle into an orbit around the galactic center, circling endlessly, just as the Sun does today. The Sun travels around the core of the galaxy at about 230 kilometers per second, yet one complete circuit takes approximately 230 million years. Across its entire lifetime, it has made only around 20 trips around the galaxy. 20 orbits is all. Even if we somehow discovered a way to reach 550 kilometers per second, then aimed directly through the thinnest region of the galaxy's halo, the distance alone would still consume tens of millions of years before we finally moved beyond the reach of the Milky Way's gravity. Now compare that with the scale of human history. Every empire, every war, every written record, and every civilization we remember fits into roughly 5,000 years. A journey out of our own galaxy would require that entire span of history to repeat itself thousands upon thousands of times along one uninterrupted straight path without ever slowing down. We are not merely slow, we are confined. So let us answer the question one final time, as honestly as possible. How long would it take to leave the Milky Way? For human beings, for our machines, and for anything we have built or can realistically imagine building, the answer is not a number of years. The answer is that we cannot do it. That limitation does not come from a shortage of talented engineers. It comes from the scale on which the universe is built, a scale so immense that the entire attempt becomes almost meaningless. The galaxy was never a place designed for us to visit and then depart. It is a prison roughly 100,000 light-years across, and we were born deep inside it. There is, however, one possible way out. Exactly one. And the most bizarre part is that we would not need to lift a finger to use it. In about 4.5 billion years, the Milky Way will no longer be alone. The Andromeda Galaxy, which appears to us today as little more than a faint blur in the night sky, is moving toward us at approximately 110 kilometers per second. It will arrive. The two galaxies will collide, passing through one another and tearing across each other's vast structures. Over the course of hundreds of millions of years, they will gradually combine into something entirely different, one enormous elliptical galaxy, already given the nickname Millimeter by astronomers. During that collision, individual stars will almost never hit one another. The gaps between stars are simply far too vast. But the paths those stars follow will be violently rearranged. Whole stellar neighborhoods may be flung outward, slingshot into the darkness along entirely new trajectories. After everything that happens, some of those trajectories could finally carry them beyond the wreckage and free them from the galaxy's gravitational hold. That may be the only way anything ever truly escapes the Milky Way, not by breaking out through its borders, but by being thrown clear when the galaxy itself is transformed. We spend our lives imagining the stars as destinations, as though the galaxy were a doorway waiting for someone to open it. It is not a doorway, it is the room. And the strangest truth is that we will never walk out of it by our own power. We can only wait for the day when the galaxy itself carries us somewhere new, whether we are prepared for that journey or not. We measure all of human history in a few thousand years, while the galaxy is so immense that it will not even allow us to leave the room.